Welcome back. Today we're going to talk about combining the transformations that we've seen in the previous two lessons. So let's say that we're asked to graph a function like this g of x up here. It's negative 3 times x plus 1 minus, it actually should be squared here. We're missing our little square. Otherwise, by the way, it wouldn't be a quadratic function unless we see that square. Okay, so what we can see is that there's an a value here. So this is a translation horizontally, this is a translation vertically, and then outside the bowl has been narrowed, right? So the 3 value narrows it, and then the negative value reflects it. So it's been first horizontally translated. So if we're working our way from inside outward, the x has been horizontally translated by -1 units, right? So imagine it jumping over here. And then the bowl, so what used to be here is now here. I'm just sort of sketching it. And then it's been reflected and narrowed, so maybe it's like this. And then it's been vertically translated down. So we're working our way outside in. So imagine you're evaluating for this x. That's the order of operations for the translation. A horizontal transformation right here, and then a narrowing and a reflection of the bowl, and then a vertical translation, okay? But in order for us to graph it, what we want to do first is we want to follow these steps. First, let's think about the vertex. Well, the vertex used to be at 0, 0, but remember, we can just think of it as this, using the HK from like 17.1, lesson 17.1. So here, our horizontal translation gets us -1. Remember, it's the opposite of what we think it is. And then we take the vertical translation at face value. So here, it's jumped to -1, -2. That's our vertex. Now, what we want to do here is make a table. And you know what? A quick way of making a table is to just actually plot it on your graphing calculator, since you're given that on the regions. So let's go ahead and plot this. We have y is equal to -3x. Actually, let's see. It's -3 quantity. Oh, let's go over. We have x, and it should be +1. And then that quantity is going to be squared. And then we are subtracting 2. Okay? Let's go ahead and graph that, right? So we see the vertex at -1, -2, and we can look at our table here. So second graph gets to our table. So here's some values that, it might be interesting for us to look at. -2, 5, -1, 2. So let's go ahead and plot those values here. Let me see if I can make this a little bit smaller here. Oh, it's not going to let me do that. So let's just plot the values that we see here. -2, 5, so -2, -5 rather. It's right here. And then we had -2, -5, -1, -2, we said 0, -5. So at 0, it should be at -5. That's right here. Oh. Okay, and then the next value we could plot is 1, -14. Let's see if we can, we actually do that. So 1, -14 would be right here. Okay, and remember, this is the line of symmetry would be through the vertex, so it would be here. So we could go 1, 2 to the line of symmetry, 1, 2 across it. So there would be another point right here. So that's enough points for us to get an understanding of what this would look like. Let me try this one more time. Draw it smoothly here. Okay. Now, when you're graphing these, both in your practice and on the regions, you want to make sure that you have enough, you've plotted enough points so that you get an understanding for what the quadratic would look like given the graph, given the graph that's written down. So here, I knew my points plotted went up to -14. So it was important for me to get these points down here, as many points as possible, so I can sort of get the shape of the parabola here. Now you'll see that all these transformations have been combined. This is a vertical and horizontal shift, along with a reflection, which is this negative, along with the bowl being narrowed. Okay, and that's exactly how you plot these transformations. So let's try one more here. Y equals 2 times, oops, again missing the square, 2 times x plus 2 quantity squared minus 1. So we can pick off the vertex. Remember, it's -3, -1. So -3 here, -1 would be here. And then let's go ahead and pick up our calculator and put this in. So we have y equals, let me clear this out, we have 2x, 2 times the quantity, x plus 3, and then we want to square it, whoops, should be x plus 3 squared minus 1. Okay, we can graph it there. We'll see again the bowl is at -3, or the vertex at -3, -1. The bowl opens upward and it's been narrowed because upward because the a value is positive, and narrowed because it's 2 is greater than 1. Okay, so let's go to our table here to get some points here. So we have -2, 1, we have -1, 7, and 0, 17. So -2, 1 right here, -1, 7 right here. And we have, let's see, this is the line of symmetry. So let me just go ahead and put this line here so it's easier. So now I can sort of plot the points across the line. So I sort of get a 2 for 1 here. Okay, so here's all I need to plot for these points, because I've used my line of symmetry to double my points here. So here again, I just went 2 over to the line of symmetry, and then I went 2 on the other side. And that's how you graph those points. Okay, so let's talk about this word problem right here. So we are given a graph here, and we have to figure out the function or the equation of this graph, essentially. So this graph shows a paintbrush that's been dropped from a house painter that's standing on a ladder. And the paintbrush begins at a height of 30 feet above the ground. Okay, that's 30 feet above the ground. And this is this path that it takes as it goes towards the ground. And the x values are in seconds, and the height is in feet. Okay, so right here, here's the general form of the quadratic equation, where you have a coefficient here, a. That's the widening or reflection of the parabola. And then we have this horizontal shift and a vertical shift. So in order to determine what so I have to fill in values essentially for a, h, and k. Right? F of t and t are the values that are given, so I don't have to, or those are the variables that I have. F of t is the height and t is the time. Okay, so so in terms of a, well, a we're going to figure out last actually, because we're going to use this point in order to plug in some values into the equation and solve for a. I know though, looking at the graph, the parabola is pointed downward, so I know that a is going to be less than, a is going to be less than -1. Because not only is it downward, but I think that it's also, the parabola is more, the bowl has been narrowed, right? Or stretched out, as we say. So let's determine that last though. Let's see, has there been a horizontal shift? Well, the vertex is at 0, 30. So it hasn't been a horizontal shift, so that's our h right here, and this is our k. So here I know that the vertex allows me to put in hk here. So I have f of t, and I know I don't have a yet, but I know t stands in for my time. H is 0 and k is 30. Okay, so let's pull everything together. F of t is equal to, well, t minus 0 is 0. T squared is just going to be t squared. So I have a times t squared plus 30. Okay. Now I'm going to plug this point in and solve it for a. So I know f of t is 14, so the height is 14 when the time is 1. So we have a times 1 second squared plus 30. We have 14 is equal to a plus 30, like that. Okay? And here, if we subtract each value here, we would have a is equal to -16. Okay, so not only has it been narrowed, but it's also negative, and we can see it's reflected, because if I drew the other part of the parabola, it would be opening downward. So finally, the function, or the height as a function of time, is -16 t squared. I didn't need those parentheses. I don't know why I put them there. It's just a source of habit. So -16 t squared plus 30 is my overall function. All right, so that's how to write a function given a graph. Now, finally, we have to figure out, this is a modeling question, so we have to figure out, this depicts two people dropping water balloons from different heights. One is 64 feet above the ground, and one is 144 feet above. It's actually pretty high. So they're dropping these water balloons, and we're wondering overall, like, what's the time that they reach the ground at? So does this one reach the ground before this one because it's traveling faster? This one, this one? Let's figure this out. So here, an object when it's falling has always an A value of -16, and that's why the paintbrush we saw last time had an A value of -16. That's like the way that gravity is interacting with the object as it's falling. Okay, so that -16 is always there when an object is falling from any height. All right. Now what we need to do is we see. So this quadratic function can be used to approximate the height, h of t, in feet above the ground of a falling object t seconds after it's been dropped from a height of c feet. So actually both of these two objects travel at the same speed, right? Every 1 second, they're decreasing their height by 16 feet, okay? So the c, though, is the distance away from the ground they started from. So here, this guy's function right here, let's call this guy h of t, or height according to t, and let's just call her, for the sake of differentiation, let's call her g of t. So h of t is going to be -16t squared, because that's how fast it falls, and it started out from 64 feet. So if you can imagine what's happening here with this is we start from 64 feet, and every 1 second, it's not every 1 second, it's every time squared, we're reducing it by 16 feet, because that's when 64 gets added to a negative, it will reduce the feet. Okay, and then g of t is going to be the same thing, but we're starting at a height of 144, so it's plus 144, okay? So here we are wondering how fast they will hit the ground. Well, what does the ground mean? Right? The ground is a height of 0. So what we can do is we're trying to solve this equation right here, right? Where this is a function, meaning there's lots of different solutions to this function. In fact, all the solutions make a parabola. Now we're making a specific equation here. We're saying what happens when what is the time when the height is 0 for each of these. So here we want to solve this equation, okay? And we can solve it just by, let's see, we can subtract 64 from both sides here. 64 is equal to -16t squared. Whoops, that should be -64. And if we divide by -16, right here, we'd have t squared is equal to, that would be 4, right? So if we take the square root of both sides here, we would get t is equal to plus or minus 2. Because remember, whenever we take a square root, we get 2 values. Well, it doesn't make sense for us to have a -2 because we're talking about time. So we're going to reject, because this gets plus 2 and minus 2, we're going to reject one of these and choose the value that makes sense for us in the context of the word problem. So this one takes 2 seconds to drop. Okay. Now this one, let's again subtract 144. From this, we have -16t squared is equal to -144. Let's divide each side by 16. Okay, and then t squared is equal to 9. So again, t would be equal to plus or minus 3, right? Whoops, plus or minus 3. But we're going to reject the -3 and take the +3 because that would make sense in the context of the problem. So this would be 3 seconds. So this person would take 3 seconds to drop, and this balloon would take 2 seconds to drop, right? And that's how you solve these questions. And now you've learned in the last module multiple different ways of solving particular quadratic equations. I could have also graphed this and asked the calculator to determine where the roots of the equation are, because essentially setting the quadratic equation equal to 0, that particular equation is called the roots of the quadratic equation. It's where it crosses the x-axis. That's another method of solving it, but I just chose a method that I knew was going to be easy for this problem. All right, and that's the end of the lesson for today.